In this video, we're going to talk about ionic bonds. So in the last video, I alluded to this, but we've been saying that if we could get sodium to lose an electron, or magnesium to, or sulfur to gain 2, or chlorine to gain 1 electron, that would make them more stable. And now I'm just now connecting that if you got an atom from a group like this, and atoms from a group like this, that they could really help each other out. And that where could those electrons come from that these 6A and 7A elements would need? Well, they could come from 1A, 2A, and 3 elements that actually be more stable if they gave those electrons up. Right? So if you want to form an ion, you need to kind of have a partner, or it kind of helps to have a partner. And so if you pair these up, you can get both atoms to have the electron configuration of a noble gas, which means that that kind of exchange of an electron, that transfer of an electron from one to the other, is kind of mutually stabilizing for both of them. And again, the classic example would be if sodium gave one of its electrons to chlorine, so I had sodium and it gives an electron to chlorine, the result is a sodium plus 1 and a chlorine minus 1. Right? And now both of these have these extra stable electron configurations. You can make the same pairing between, say, a sulfur and a magnesium, or any we want to start thinking about these in terms of kind of any of these guys, right? So I could have potassium, and potassium could give up its 4s electron to chlorine, or you could have cesium give up its 6s electron to fluorine, right? So all of these are kind of possible pairings. You could have beryllium give up 2 of its electrons to oxygen, right? And it's kind of like, as long as the electrons have a place to go, right, and it kind of makes everything more stable, then that's something that's kind of energetically favorable. So once that happens, so now we have our sodium ion, sodium cation, and our chlorine anion. Well, what's going to happen? Well, we learned in the electromagnetism unit that if you have something that's net positive and something that's net negative, they attract. So what you'll get is this sodium ion and this chlorine ion kind of stuck together. And this is now called an ionic compound. And that's because there is an ionic bond, so that Coulomb's law attraction, Coulomb's law, right? That's saying that positive and negative will attract. Forms that bond. They're now stuck together. And that's called an ionic bond because it's between two ions. And it's got to be between a positive and a negative ion, right? Or there won't be an attraction. So it won't happen between 2 sodium ions or 2 chlorine ions because they'd both be positive or negative respectively. So that's what an ionic bond is. And an ionic bond, again, is just, it's the attraction, it's kind of a bond, right? Again, they would be kind of stuck together in this way, attracted to each other, because of the attraction between the positive and negative ion. How do those positive and negative ions form? Well, electrons have to be transferred from one to the other. So we could also say magnesium could transfer 2 electrons to oxygen, and we would get something similar. We would get Mg2+, and oxygen 2-. Hey, guess what? They're going to attract, and we could call that MgO. Just like we could call NaCl just NaCl. And this is table salt, by the way. And you can think about all the other kind of mix matches that you could have. You could have lithium and fluorine, etc., etc. In the next video, we'll talk about some of those combinations and how to balance those out.